Assalamualaikum warahmatullahi wabarakatuh. Thank you for the chance that given to me. It is an honor to be presenter in this conference. I am Sulistyowati as the second author on this paper. I'm from Department of Civil Engineering, University of Mataram. In this opportunity, I would like to present about numerical simulation of slope stability for soil embankment reinforced with inclined bamboo piles. So this is the outline of our presentation, divided in 5 parts. First, introduction, shear strength reduction, finite element method, numerical simulation, result and discussion, and the last conclusion. Okay, let's start with introduction. Background of this study. Slope stability is an important parameter when designing embankment roads, highways, dams, and other civil engineering structures. Some triggers that causes the failures of slope: poor quality soil material, degradation properties of soil material will decrease in the shear strength of the soil, so it needs slope reinforcement. Several slope reinforcement techniques widely applied are geosynthetics, soil nailing, concrete or steel monopile, concrete block, etc. But the technologies that require skilled labor and relatively expensive. As we know that bamboo is a natural material widely available globally, especially in Asia. Bamboo, also green building material, renewable, sustainable, typically be harvested in less than 3 to 4 years and relatively cheaper. Bamboo culm, then the Calamus asper or bamboo petung in Bahasa, provided with diameter 6 to 15 cm, length until 13 meter. Also have highly tensile strength, almost similar with soft steel reinforcement. So that's why we can use inclined bamboo pile as an alternative material used in slope reinforcement. Next, this is some literature review. The research about utilization of bamboo piles for slope stability were conducted by several researchers. Generally, there are 2 methods for slope stability analysis. First, limit equilibrium methods such as ordinary, Bischoff, Janbu, Spencer, Morganson, Price. But limitation of the limit equilibrium method, the critical slip surface has to be estimated. The second is numerical analysis methods such as finite element method. The advantage of the finite element method is no potential slip surface was estimated in advance, and stress-strain correlation in the slope can also be considered. The aim of this numerical study is to analyze the performance of the slope reinforced with inclined bamboo pile as an alternative material used in slope reinforcement. The variation of diameter bamboo pile was modeled to evaluate influence inclined bamboo piles to the safety factor. More column material model shear strength reduced by a factor of safety can be determined from the equation below. There are 3 soil parameters: cohesion, friction angle, and dilatation angle. More column shear strength parameters, and these values can be input into the Abacus student edition software and then analyzed. This is the input of soil material in Abacus student edition. There are several types of criteria for determining the failure slope model: numerical iteration, non-convergence, suddenly change displacement, plastic strain or equivalent plastic strain. Let's turn to numerical simulation. This is step-by-step modeling with Abacus Student Edition. There are 3 steps. First, model geometry. The geometry of homogeneous embankment slope model was typically 20 meters in height and 35 meters long at the base with an inclination of 33.69 degrees. The bamboo pile with 5 meter length, and the diameter variation are 6, 10, and 15 centimeter. For them, that is placed 2 in the edge, 1 in the middle, and insert perpendicular to the slope model plane. Material properties, there are 2 material, soil material and bamboo pile. Soil material assumed to be undrained and saturated clay. There is elastic plastic column model, and the parameter of modulus elasticity, Poisson ratio, cohesion, friction angle, and unit weight. The dilation angle is 0 degree because saturated clay and undrained. Bamboo piles, there is modulus elasticity and Poisson ratio. And the last step is meshing. There are 1,185 elements, type CPA3 for soil and B21 for bamboo piles. Boundary condition, roller in beside and fixed in bottom. For loading, just gravity load. Okay, let's continue to the next slide. It's result and discussion. From this chart and this table, factor of safety for clay embankment slope unreinforced increased slightly from 1.298 to 1.5 after reinforced with bamboo pile. The factor of safety depends on the diameter of bamboo piles. Larger diameter of bamboo piles, the factor of safety were increased. Okay, next, the equivalent plastic strain. There are 4 slope model. Slope model unreinforced. Slope model reinforced with inclined bamboo piles, diameter 6 cm, 10 cm, and 15 cm. The red color of this is the red color is shown the critical slip surface. The different contours shown in the figures indicate the location where the slope failure started. Okay, this is the last slide. Conclusion. The conclusion from the simulation of the slope model by using Abacus Student Edition software were obtained as follows. The factor of safety of the slope depends on the diameter of bamboo pile. When the bamboo pile were inserted in the slope, it also changed the stress strain and failure mechanism. The equivalent plastic strain contour indicates the location of the potential failure of the slope. The shear strength reduction finite element method can be used as an alternative for slope stability analysis of soil embankment slope model reinforced with inclined bamboo piles. So that's all about our presentation. We will try to answer all questions you may have Well, thank you very much for your great attention. May all those we have shared be beneficial for all of us. Wassalamualaikum warahmatullahi wabarakatuh.